Hi guys, what's up? Welcome to lesson 1-11, which is all about adding and subtracting radicals. The objective, what you should be able to do by the end of this video, is you should be able to add and subtract radicals and express your answer in simplest form. Please go ahead and turn in your notebooks to lesson 1-1. And as a friendly reminder, if you would like to color code your notes along with me, that is fine. For the teacher page, student pages should be completed in pencil. Also, please ensure that your notes look exactly like mine. So the first thing to take note of is that you must have the same radicands in order for you to add or subtract radicals. That is super duper important. So in your stop sign, please go ahead and record this note. Again, ensure that your notes look exactly like mine. You must have the same radicands in order for you to be able to add or subtract. Now that we've established that you must have the same radicals, what do? So you'll either need to add or subtract your coefficient based on the operation that's been given to you, and then next you'll keep your radical exactly the same. Now that you have down this note, let's take a look at the next two examples. I see I have 5 radical 6 plus 7 radical 6. I notice that the radicands are the same, so that's why I'm giving it a thumbs up. Now that I've established that, I can go ahead and in this case add my coefficients because I see the operation of addition. My first coefficient is 5 and my second coefficient is 7. If I go ahead and add these coefficients, 5 plus 7 will give me a sum of 12. And then step 2 says to keep the radical the same, so my final answer will be 12 root 6. Taking a look at the second example, I have 4 root 3 minus 9 root 3. The first thing I'm checking for are to see if my radicals are the same, and in this case they are. Both radicals have root 3. And so now I can go ahead and subtract my coefficients in this case, which is 4 and negative 9. So 4 minus 9 will yield a difference of negative 5. And then I'm keeping my radical the same, which is root 3. So my final answer will be negative 5 root 3. So the most important thing to remember is that when you're adding or subtracting radicals, you must have the same exact radicand. If it is not the same, then we're going to take a look at what you do down below. So you'll see these stressed emojis because they're not sure what to do. The radicands in the examples down below are different. So now, when that occurs, you have to ask yourself this question. Are the radicals that I've been given expressed in simplest terms? If yes, then we're going to follow the track to our left. If I've been given an example to add or subtract, and my radicals are expressed in simplest form, then I cannot combine the terms because the radicands are different. Because the terms cannot be combined, I would just have to rewrite the problem exactly the same way it was been given it to me. So let's take a look at the example down below. I have 5 root 2 minus 8 root 7. I see that root 2 and root 7 are different. I also know that there is no perfect square that evenly divides into root 2 or into root 7. Therefore, I know that these expressions are in simplest form. Because the radicals are in simplest form and they are different, I cannot combine unlike terms. The only thing that I can do is rewrite the problem exactly the same way I see it and draw a box around my final answer. Now let's take a look at the next type of situation in which I have different radicands. However, my expression is not in simplest terms. If this is the case, then I will have to simplify the radicals. If the simplified terms have the same radicand, then I can combine the coefficients. If the simplified terms have different radicands, then I will just rewrite the simplified radicals and place a box around my final answer. Taking a look at this first example, I have 7 root 9 plus 6 root 25. I know that root 9 is a perfect square, so therefore this will simplify to be 7 times 3, because the square root of 9 is 3, plus 6 times 5, because the square root of 25 is 5. I know that it's multiplication that's going in between these two, because my 7 was right next to my radical 9, and my 6 was next to radical 25. I know that 7 times 3 is 21, and 6 times 5 is 30. So now I will find that sum, which equals 51. That worked out really nice because I had perfect squares. What happens if I don't have perfect squares? I would still have to go through the process of simplifying my radicals. So taking a look at this example, I have root 12 plus 9 root 3. I can see that root 12 and root 3 are different. Now I have to ask myself, can these be simplified? And it can. The largest perfect square that evenly divides into root 12 is root 4. And root 4 times root 3 would give me back my original radicand of 12, because 4 times 3 is 12. The square root of 4 is 2, and 3 does not have a perfect square, so I'll just rewrite it, and now this simplifies to be 2 root 3. I can then carry down the remainder of the problem, so now I have 2 root 3 plus 9 root 3. Since my radicands are the same, I can then identify my coefficients and add them. My coefficients are now 2 and 9. And I can add them because I have the operation of addition. 9 plus 2 is 11. And then I will keep root 3 the same and place a box around my final answer. This concludes our mini lesson for lesson 1-11, adding and subtracting radicals. As a reminder, please ensure that your notes look exactly like my notes. If you need to rewind the video to ensure this, please be my guest. Also, as a pleasant reminder, what you are going to complete now are your student pages that look like the following. The first one looks like this, and the second page looks like this. Please ensure that you are using pencil when you're completing the student page. Also, please ensure that you are showing all of your work as you are going through and answering these questions. Questions that only have a final answer and no work shown will receive no credit. Happy mathing, guys!